IndexCache. New AI optimization speeds long context models by up to 82%. Researchers have developed IndexCache, a new technique to dramatically accelerate large language models, LLMs, processing extensive data. This optimization delivers up to an 82% faster inference speed on long context AI models, addressing a critical bottleneck in the field. The core problem: LLMs struggle with computational costs as context windows expand, making advanced applications like document analysis, agentic workflows, and complex reasoning slower and more expensive. The bottleneck in sparse attention: modern LLMs use sparse attention to handle long sequences efficiently, rather than comparing every token to all others, which scales quadratically with sequence length. Sparse attention focuses on only the most relevant tokens, drastically reducing compute. DeepSeek Sparse Attention, DSA, is a leading implementation, but even it has a flaw. The lightweight Lightning Indexer module, used to select relevant tokens, still introduces quadratic complexity at every layer. This means as context grows, indexing itself becomes the limiting factor. IndexCache. Reusing the work IndexCache solves this by recognizing that the most important tokens selected by DSA indexers remain consistent across multiple layers of the model. The technique divides model layers into two types: full F layers, which actively index tokens, and shared S layers, which reuse the cached indices from the nearest preceding F layer. This eliminates redundant computation without sacrificing accuracy. IndexCache attacks the compute bottleneck rather than just memory footprint. It is complementary to existing approaches. Yuxi Bai, co-author of the paper Deployment, Training-Free or Native Optimization, the research team offers two ways to implement IndexCache. Training-Free. A greedy layer selection algorithm identifies the optimal placement of F and S layers using a small calibration dataset. This method removes up to 75% of indexers without retraining the model. Training-aware, teams can fine-tune models with a multi-layer distillation loss, forcing indexers to learn shared token selections across layers. Real-world results. Speed and cost savings tests on the 30 billion parameter GLM47 flash model show IndexCache delivers significant speedups at 200K context length. Prefill latency. Reduced from 19.5 seconds to 10.7 seconds, 1.82x faster decoding throughput. Increased from 58 to 86 tokens per second, 1.48x faster total decode throughput. Improved by up to 51%. These gains translate into 20% lower deployment costs for long context workloads like RAG, document analysis, and agentic pipelines. The model's reasoning abilities remain unchanged, even outperforming the baseline on complex benchmarks like AIME 2025. Future implications: IndexCache isn't just a temporary fix. It represents a shift in model design. Future LLMs will likely prioritize inference constraints during the design phase, optimizing for real-world throughput and latency rather than treating them as secondary considerations. In conclusion, IndexCache offers a substantial leap in long-context AI efficiency, making advanced applications more practical and affordable. The open-source patches are readily available for major serving engines, enabling developers to integrate this optimization into existing infrastructure with minimal disruption.